Hello everyone and welcome back to our next lecture in our blockchains course, Architecture, Design and Use Cases. Before we start, I must thank a lot of my colleagues at IBM who have made some of these presentations available over a period of time. So I've collected this from many different sources, but a lot of the IBMers have helped prepare some of these slides, so I have many thanks to say to them. So we've been looking at some of the details of Hyperledger Fabric itself, and in this lecture, we're going to talk about how you can set up your own Fabric network. So what are some of the things it takes? What are the steps it takes to set that up? So the first step is, like I mentioned earlier, is the ordering service. So that's the main component that is going to determine how transactions are ordered in the network, and that'll be the first thing you set up or you bring up in the network. So it could be a single solo ordering node, or it could be a distributed set of nodes that are running an ordering service, let's say a Kafka consensus that they execute. So that's the first ordering service that's the first component that you bring up. And there's a simple CLI command for you to bring that up, or you can also use the SDK that is available in multiple languages in Java, Node.js and Python. So once the ordering service is up, then the next step is to configure and start peer nodes. So you could have multiple organizations that are part of this blockchain network. Each of those organizations could run one or more peers. So you will have, of course, all the identities have to be set up when I say you're bringing up each of these entities. I'm assuming that when you brought up the ordering service, the identity for the ordering service is set up. And likewise for the peers, each of these peers and their respective organizations have their identities, right, with an MSP and provided by a certificate authority. So each of these peers have to be brought up. So again, there are simple CLI commands and SDK commands that you can use to bring these services up. So each of these peers, like I said, could belong to different organizations. So that now the peers are up, but they're still not connected to each other in any way. Once you bring up these peer processes, the next step may be to install one or more chain codes on these peers. Again, when I say install, this is just to bring up the process that will run the business logic. Again, this is not connected in any way to the rest of the system. So this peer will then have a container that runs the chain code A, again another container to run chain code B, likewise for all the other peers. Again, a very simple command both from CLI and from SDK will enable you to install these chain codes on the respective peers. And also note the fact that the chain codes can be installed on only a subset of the peers in the network. It doesn't have to be installed on all the nodes. So you can decide who are the endorsing peers for each chain code, and you can install the chain code only on the endorsing peers. So this does give you a notion of privacy in the sense that the code itself, the business logic that you are executing in a decentralized fashion can be executed amongst a subset of the organizations you have in the network. It doesn't have to be all the organizations or all the peers. Okay, so now you have the ordering service, you have a bunch of peers, you have chain codes installed in them. Now is when you start constructing the network itself and the communication between them. So you're going to be creating some channels. The ordering service is where these channels are configured. So of course you could also have multiple ordering services for these different channels, but in this example, let's assume that there is just one ordering service again, that ordering service has multiple nodes, so a distributed ordering service, and it has multiple channels. So in this case, there is a red channel, a blue channel, and a yellow channel. So all these channels are configured with the ordering service. And when you're configuring the channels with the ordering service, you're also going to be joining peers in that channel as the next step. So the channel configuration will include the set of organizations and set of peers that are part of that channel. So in this case, E0 and E2 have joined the blue channel. E0 and E1 have joined the red channel. E2 and this P3, which is not an endorsing node, have joined the yellow channel. And actually, the blue channel also has E1 and P3. So the blue channel has E0, E1, E2, and P3. So all the nodes are part of the blue channel. So this way, it's possible to have different subsets of nodes join different channels. And channels, like I mentioned, are a notion of provide a notion of privacy across the different transactions and the different state you want to maintain in the network. So that same peer can be part of multiple channels. So again, there's a simple CLI command, and again you can do the same thing using SDK. So it could be a client application as part of setting up the network, could be executing all of these steps, or it could be different nodes. So basically, if these nodes are part of different organizations, their respective client applications would have to join their peers to the channel. The next step is to instantiate the chain code on channel. So you have to say, you have the chain codes running on the peers, but you have to say which chain code belongs to which channel. So again, this is highlighted, if you see, as the border color here in each of these boxes. If you take the channel red, then chain code B is part of the channel red. So the chain code B is instantiated on that channel. So it will have its ledger, and it can add transactions to the chain, to the blockchain in the red channel. Likewise, the yellow channel again has chain code B alone. So the yellow channel has only one endorsing peer, which is E2. It alone runs this chain code B, and it's connected to the yellow channel. So it will have its ledger and a block of transactions. The blue channel has all the peers, and chain code A is part of the blue channel. So you can see the chain code A has this blue border. So the chain code A will be part of the blue channel, and all transactions on the blue channel will be functions that are invoked on chain code A. So this is just an example network to show the flexibility of the system. So you can define which peers, you can define the channels first. You can define which peers, which organizations are part of which channels. You can also define which chain codes are part of which channel. And all of these are segregated separately. So each chain code state is separate from another in each channel, right? So that's how it's maintained. And all the chain code state across the peers in a channel are all consistent. So all the state will be maintained consistently using consensus. Again, a very simple CLI command is available for you to execute and set this up. So with this, if you see, the whole network is set up, and now users can perform transactions on this network. So on the red channel, users can invoke functions of chain code B. Again, same thing for the yellow channel, users can invoke functions of chain code B. On the blue channel, they can invoke functions of chain code A. So that's how it's separated out. I mentioned that it's possible to have just a subset of the peers executing chain codes on each channel, and that is governed by the endorsement policy. Right? So the endorsement policy states which peers have to execute and endorse a transaction before it will be deemed as valid to be added to the blockchain. So each chain code defines an endorsement policy, and this can be different for each channel, right, that the chain code belongs to. Now there are two important system chain codes. So these are the system chain codes are chain codes that are implemented internal to Fabric itself that perform certain important functions. We'll talk about two of these system chain codes. There are I think 3 or 4 more of these system chain codes that have been added. Again, these system chain codes also provide the notion of pluggability. So although I mentioned these two system chain codes, you can always think about other implementations with other properties that these system chain codes provide. So the first system chain code that is of importance is the endorsement system chain code. What it does is, so this system chain code is going to be running within every endorsing peer. So when a client submits a transaction to a peer, so this is an endorsing peer here. When a client submits a transaction to the endorsing peer, it is a transaction that is invoking a particular function that is in the chain code, and it first comes to the ESCC. So the ESCC, the endorsement system chain code, is the one that will invoke the chain code, will execute the transaction. It will compute the read-write set of the transaction. So what is the state information that was read in the chain code in that function? What was the state information that was written? All of that is captured by the ESCC, and it will then sign the proposal response. So it will then sign this and say, okay, when I ran this transaction, this is the read set, this was the write set, and here is my signature saying that I was the one who ran this and I endorse this. So this is done by every endorsing peer, and the system chain code does that signing part of it. Now client collects all of these signatures from like all the endorsements. It will then submit the transaction to the orderer. The orderer will include it in the block, deliver it to the peer, and now all committing peers are now going to do certain functions, right? So that's where the validation system chain code comes in, which is going to validate these endorsements. So what does the validation system chain code do? It will look up the policy for this particular chain code. So this policy might say organization 1, 2, and 3 in the network have to sign this transaction. So it will then check whether those 3 signatures are available. The other policy, we'll look at some of these policies, that how the syntax works for some of these policies. But the validation system chain code does the job of going through the endorsements that are available in the transaction, that have been submitted with the transaction, and seeing if that set of endorsements satisfy the policy that was specified for that chain code in that channel. So that is the validation system chain code. Now it's always possible that the endorsement, you want to use some other logic for the endorsement, or for the validation you want to use some other logic for the validation, or even you might want to implement that in a different language rather than Golang. So all those possibilities exist, and this whole module is pluggable, and you can bring in your own implementation for these things based on your application needs. But for most applications, we deem that these existing implementations of endorsement system chain code and validation system chain code will be sufficient for most applications that we see in the enterprise world. To give you a comparison with Bitcoin, the validation that Bitcoin does, in some sense, is the validation whether the transaction is a duplicate or not. So this is the UTXO model, whether the transaction is unspent amongst all the previous transactions that this network has seen. Right? So that's the UTXO model. All it does is verify whether this transaction is unspent or not. So here we are not following the UTXO model. We are following what is popularly called as the state-based model. So the validation is based on state information that we are storing in as part of the ledger. And the validation here, specifically one part of the validation, is the validation of the endorsement policy. So this is different from what Bitcoin has, and this is very specific to Hyperledger Fabric, and it's also one of the differentiators of Hyperledger Fabric. So looking at a little more detail about the endorsement policy itself, how do you define it, how do you specify it? When you are instantiating a chain code, this is just an example of a chain code instantiation. You are providing first the channel on which you are instantiating this chain code. MyCC is the chain code name. You have a version for the chain code, so it's possible for you to deploy multiple versions of the chain code that may be improvements of the chain code over time, maybe changes in the business logic can be captured. So the chain code itself can follow a full life cycle, and there is a separate system chain code for that, a life cycle system chain code that manages the life cycle of the different versions of a chain code. So that's a separate, so that's the version of the chain code. And then you have a particular code that it refers to. So that's a particular smart contract, that implementation. And then the input arguments for that chain code, right? So these are the initialization arguments. So it's called you're calling the init function with a certain set of parameters. So this could be any parameters that you choose to pass at the time of initializing the chain code. So this chain code takes 4 initialization arguments. So I think this chain code example 02, if you're looking up the Fabric code and the examples there, it actually sets the account balance of A to be 100 and an account balance of B to be 200. So that's the initialization that we are doing. And the -P option here gives you the endorsement policy. That's what we are looking at here. So what does this endorsement policy says? The endorsement policy says that org1 MSP, any entity of org1 can sign this transaction. So this is the AND policy. So it's possible the syntax for the endorsement policy is any expression using AND and OR gates, and using any principal or nested expression. So I can say org1 MSP.member and org2 MSP.member. So both of these entities must sign. And the principal that I called out here is really a particular role. It could be member, it could be admin. These are the supported roles today. And the MSP is a particular MSP ID. So there is an MSP called org1 MSP, and there is a role called member within the org1 MSP, and anyone who has the member role in org1 MSP can sign this, can endorse this transaction. Now it is also possible to have a N out of K policy. So that's possible to say 3 out of the 5 organizations, you specify the list of 5 organizations and say any 3 out of the 5, if they are signing this transaction, then I will consider that as valid. So the N out of K signing is also possible. That's also part of the policy syntax. Here are just some examples of policies. So one example could be and of org1 member, org2 member, org3 member. So in this case, org1, org2, org3 are really MSP identifiers for their respective organizations. Member is the role within those organizations. So a member of org1 has to sign, a member of org2 has to sign, a member of org3 has to sign. All of these together now will satisfy the policy. The other policy you can do is or. I can say org1 member or org2 member must sign this transaction. That will be the endorsement. And it's also possible for you to include arbitrary combinations of and or. Like in this example. What this example says is, first let's look at the inside thing. org2 and org3 must sign it. org1 must sign it. So that is the condition. So it's either org1 or a combination of org2 and org3 must endorse this transaction for it to be valid. So you can have any arbitrary combinations of this endorsement. So based on for each transaction who has signed it, the specific members who have signed it, we will then compare as part of the validation system chain code. We will compare it with this logic, this policy that you've specified, and validate whether the policy is satisfied or not. So this is just a satisfying satisfaction, Boolean satisfaction. And if it is satisfied, then we will admit that as a valid transaction. So each at the time of the validation stage, each peer is going to execute this and validate whether it's satisfied. Okay, so that again, likewise, there can be an N out of K policy also. I have not given the example here, but you can look up the documentation for that. So it's also possible to define, say, N out of K members in the network have to sign. So this actually concludes all of the material for understanding what really Fabric is, how it's designed, how the network setup is made. So there's a lot of material that is available for you to quickly get to the next level of detail, right? So the home page for Fabric itself is under the Hyperledger project. It's available there. You can look up the code, and there is some interesting examples that are shared along with the code. So there is a Gerrit repo as well as a GitHub mirror of that Gerrit repo. Some of the latest docs, this keeps updating based on new features. New features are getting added almost on a weekly basis. And there are multiple features that are being proposed actively, and they're also being developed actively. So we are right now in version 1.1 of the Fabric. Version 1.2 is being planned, and there'll be a release later this year. There's a community chat. If you're a developer, you have some issues with some understanding, or some part of your code is not working, you have a defect that you want resolved, you can always go to chat, and there's a very active community out there that takes an interest in answering others' questions. So very active community that helps all developers mutually. Right? So, and there's also a wiki where you can also find more information. Over the next few lectures, what we will do is we will go through some demos. I'll try and show you Fabric in action. So there are many ways in which you can set up Fabric. You can set it up on the cloud very easily. You can set it up on your own laptop or on your favorite development environment, set of VMs, Docker containers. Wherever you want to set up, there are instructions for you to get started very easily. So you can set up your network in a matter of maybe tens of minutes maximum. And on the cloud, it's just a couple of clicks. You can get going. So I'll show you some of those, and I'll also show you how a network is set up. Maybe show you some examples of how a smart contract is written. So we'll go through some of those demos over subsequent lectures. So to conclude, some of the fun reading section, some of the additional information you can get. There is very easy instructions to, if you are a do-it-yourself kind of person, very easy instructions for you to set up your own network in any kind of development environment, any kind of operating system. That should be okay. There's also a quick start guide for developers on how you can get started, and very easy instructions for you to get started. So with that, thank you. That concludes our lectures on Hyperledger Fabric. See you in the next set of lectures for seeing some demos of Fabric in action. Thank you.